Alright, let's start with something that sounds like it came straight out of a sci-fi movie. Black holes. But don't worry, we're not talking about intergalactic monsters or anything like that. A black hole is basically a region in space where gravity is so strong that nothing, not even light, can escape it. Yeah, that's right, not even light can get out. So if you tried to take a picture of a black hole, you'd just see darkness. That's the whole point. Now, how do these cosmic vacuum cleaners form? Well, they start with stars. Stars are like giant balls of gas, mostly hydrogen, burning through nuclear fusion in their cores. But not all stars end up as black holes. Only the biggest ones, those that are at least 3 times the mass of our sun, have the power to become one. When these massive stars run out of fuel, they can't support themselves against gravity anymore, and boom, they collapse under their own weight. This collapse is so intense that it compresses the star's core into an incredibly small space called a singularity. The singularity is like a point with infinite density, where all the mass of the star is concentrated in a tiny area. Around this singularity is what we call the event horizon, which is basically the point of no return. Once anything crosses the event horizon, it's gone forever. No escape, no rescue, no second chances. But here's the kicker. Black holes aren't just empty space. They're actually some of the most powerful objects in the universe. Their gravity is so strong that they can bend light and warp spacetime around them. This effect is called gravitational lensing, and it's like looking through a giant magnifying glass made by the black hole itself. Scientists use this to study distant galaxies and even look for dark matter. And let's not forget about the accretion disk. That's the swirling disk of gas and dust that orbits around a black hole. As this material spirals inward, it heats up to unimaginable temperatures, emitting X-rays and other forms of radiation. It's like a cosmic firestorm, but instead of flames, you've got superheated plasma. This is one of the ways scientists detect black holes, by looking at the light they emit as they devour nearby matter. Alright, let's talk about the event horizon, because if you're reading this, you probably already know that black holes are super intense. But here's the kicker. The event horizon isn't just a fancy name for the edge of the black hole. It's actually the point where gravity is so strong that not even light can escape. Yep, that includes your favorite TV show or any other light-based entertainment you might be watching right now. So if you're ever caught in a black hole, don't expect to see the next episode of Stranger Things. You'll be stuck forever. Now, imagine standing on the event horizon. You'd feel like you're at the edge of a cosmic abyss, and once you cross it, there's no going back. It's not like a normal door that you can just walk through and come out the other side. Once you pass this point, you're in for the ride of your life. Literally. The gravity is so intense that space itself is being pulled into the black hole, and you'd be stretched like spaghetti by the time you get there. Scientists call this spaghettification, and it's not a fun party trick. But here's where things get even more mind-blowing. The event horizon isn't just a physical boundary. It's also a point of no return in terms of information. Once something crosses it, we can't observe what happens inside. It's like trying to watch a movie through a one-way mirror. Once you're on the other side, there's no way for anyone else to see what's going on. This has led scientists to wonder if black holes are just cosmic trash bins that swallow everything and leave nothing behind. And let's not forget about time. The event horizon warps time so much that for someone falling into a black hole, time would appear to slow down dramatically from the perspective of an outside observer. It's like watching a clock tick slower and slower until it almost stops. But for the person falling in, they'd experience time normally, until they're pulled into the singularity at the center. So if you ever wanted to live forever, maybe jumping into a black hole is the way to go. Well, unless you want to end up as a spaghetti-like mess. But here's the catch. We can't actually see the event horizon itself. It's not like there's a glowing ring or anything that we can observe with our telescopes. Instead, scientists use indirect methods to detect it by observing how light and matter behave around black holes. They look at the way gas and dust swirl around the event horizon, creating a bright accretion disk that glows due to friction and heat. It's like watching a cosmic dance where everything is moving so fast that you can't even see the actual edge of the black hole. Alright, let's dive into the very core of a black hole, where things get weird and physics starts to break down. This is the singularity, that tiny point at the center where all the mass of the black hole is compressed into an infinitely small space. Imagine taking the entire Earth and squishing it into something smaller than a grain of sand, but then doing that with millions of times more mass. Yep, that's what we're talking about here. Now, you might be thinking, wait, isn't a black hole just a supermassive star that collapsed in on itself? Well, yes, but once it collapses past a certain point, gravity becomes so strong that not even light can escape. And at the very center of this gravitational monster is the singularity, a place where our current understanding of physics hits a wall. Einstein's theory of general relativity works great for describing gravity in most situations, but when you get to the singularity, it falls apart like a broken toaster. So why is the singularity such a big deal? Because it's not just a point. It's a place where all the known laws of physics stop working. Time and space as we know them lose their meaning, and gravity becomes so intense that it warps reality in ways we can't even begin to imagine. Scientists are still trying to figure out what exactly happens there, and some theories suggest that the singularity might be a gateway to another universe or a place where time loops back on itself. But here's the kicker: we've never actually seen a singularity. All our observations of black holes come from their event horizons, the point of no return, so we're basically guessing what's going on inside based on math and theory. Some scientists think that quantum mechanics might be needed to understand the singularity, since at such tiny scales, particles behave in strange and unpredictable ways. It's like trying to predict the weather using a calculator made of jelly. In fact, some physicists believe that the singularity might not even exist as we think. They propose that instead of a point of infinite density, there could be something else, maybe a quantum foam or a different kind of structure altogether. This is where theories like string theory and loop quantum gravity come into play, trying to reconcile general relativity with quantum mechanics in the hopes of solving this cosmic puzzle. Alright, let's talk about time and space near black holes because, honestly, it's like the universe is playing a cosmic prank on us. Imagine you're standing right next to a black hole, and suddenly your watch starts ticking slower than your friends back on Earth. That's not a glitch in your phone, it's called time dilation, and it's one of those mind-bending facts that makes physicists go, wait, really? Time isn't just a straight line. It's more like a rubber band being stretched by the black hole's gravity. The closer you get to the event horizon, the slower time moves for you compared to someone far away. So if you were to jump into a black hole and come back out, you'd find that years have passed on Earth while only minutes have gone by for you. That's not just sci-fi. It's real physics, and it's wild. But wait, there's more. Black holes don't just mess with time. They also warp space in ways that would make a GPS satellite jealous. Picture this. Light from distant stars or galaxies tries to pass near a black hole, but instead of going straight, it gets bent like a spoonful of gelatin being squished by a giant hand. This phenomenon is called gravitational lensing, and it's basically the universe using gravity as a magnifying glass. Scientists use this effect to study things that are too far away or hidden behind other objects. It's like having a cosmic telescope built into the fabric of space itself, except instead of lenses, we're using black holes. And honestly, if you could see it, it would look like a weird halo around the black hole, which is both beautiful and terrifying. Now, here's where things get even stranger. Near a black hole, space isn't just curved. It's stretched so much that it can create what scientists call spaghettification. No, not the pasta. It's when the intense gravitational pull stretches an object into a long, noodle-like shape. Imagine you're falling toward a black hole and your feet are pulled harder than your head because gravity gets stronger as you get closer. The result? You'd be stretched like taffy until you're basically a spaghetti strand. That's not just a fun fact. It's a real danger for anyone who dares to get too close. So, while the idea of time dilation is mind-blowing, spaghettification is more like a cosmic warning sign that says, don't come any closer. But let's not forget about the black hole's event horizon, the point of no return. Once you cross it, there's no going back because the gravity is so strong that even light can't escape. And here's the kicker. Time near the event horizon behaves differently than we expect. If you were to hover just outside the event horizon, time would pass slower for you compared to someone far away. In fact, if you could somehow stay there forever, you'd see the entire future of the universe unfold in front of you while only a few seconds pass for you. That's not just a sci-fi plot. It's a real consequence of Einstein's theory of relativity. So, if you ever find yourself near a black hole and time starts moving at a different pace than your friends back home, don't panic. Just remember, it's all part of the cosmic game. In summary, black holes are more than just cosmic vacuum cleaners. They're master manipulators of time and space. They bend light with gravitational lensing, slow down time with time dilation, and can even stretch you into a noodle if you get too close. So next time someone says they want to explore the universe, make sure they're not planning on getting too near a black hole. After all, it's one thing to be a scientist, but it's another to be a cosmic spaghetti strand. Alright, so you've heard about black holes, right? Those cosmic vacuum cleaners that suck in everything, including light. But here's the kicker. Once something crosses the event horizon, it's basically gone forever. But wait, what happens to all that matter? Is it just destroyed? Or is there some weird physics happening inside that we can't even begin to comprehend? Scientists are still trying to figure this out, and honestly, they're not even sure if they'll ever know for sure. The first theory you might have heard of is the singularity idea. That's where all the matter collapses into a single point with infinite density. But hold on. How can something be infinitely dense? It sounds like a math trick more than real physics. Plus, if that's true, then what happens to time and space near that point? Time would basically stop, and space would fold in on itself like a cosmic origami. Sounds like a party crasher with no invite. Then there's the information paradox. A mind-bending problem that has scientists scratching their heads for decades. You see, when matter falls into a black hole, it seems like all the information about what it was made of gets lost forever. But quantum mechanics says information can't just disappear. It has to be somewhere. So where is it? Is it trapped inside the black hole? Or does it somehow escape through some mysterious process we haven't discovered yet? This paradox is like a cosmic game of hide and seek with no rules. Some scientists think that maybe black holes aren't as destructive as they seem. They propose that instead of crushing matter into a singularity, the black hole might actually create a wormhole, a tunnel to another part of the universe or even another dimension. That's right, wormholes. Think of them like shortcuts through space-time. But here's the catch. These wormholes are unstable and would collapse almost instantly unless something keeps them open. So, if you're planning a trip to another galaxy via black hole, better bring a lot of stabilizers. And then there's the idea that black holes might not be as black as we think. Some theories suggest they emit radiation called Hawking radiation, which slowly causes them to lose mass and eventually evaporate. But if that's true, what happens to all the matter that fell into the black hole? Does it get spit out in some form, or does it just vanish along with the black hole itself? This is like a cosmic version of a black hole. Everything goes in, but nothing comes out, except maybe radiation.